So good morning, learners. Welcome to our today's lesson. Our science lesson today is going to cover current electricity. Just to remind you what we are doing in our last lesson, we were doing static electricity, and we said static electricity is electricity that is at rest. At rest meaning that there is no movement from one end to another. We also discussed about the balloons. And in the balloons we said when you inflate two balloons and you don't charge them with anything and you bring them together, so two balloons and charge, two balloons and charge, we said nothing happens. Nothing happens. Then two balloons, one balloon charge and the other uncharged, uncharged. We say that still nothing happens. Two balloons charged using the same kind of material. We said they repel because they acquire the same charges. Then we say two balloons charged with different materials will attract one another. So that's all about the balloons. Today we want to discuss about the current electricity, and the word current here means that there is movement. So generally we have sources of current electricity. We're saying that factories, schools, and most homes use electricity generated from. So we have the big dams. We get electricity from big dams. We also get it from diesel generators. We also get the same from wind-driven generators. We also get it from geothermal wells, and also from solar cells, what we call solar panels, the ones that are put on top of the roof, and they can acquire light and transform that light into electricity. So what we call current electricity is just electricity that is not at rest. We say this is at rest. You can also say stationary. But now current electricity is not electricity that is at rest. It is electricity that can move. So current electricity is a kind of electricity that can move, meaning that it can move from one place to another. Whenever you, for example, you connect dry cells, two of them like that you have your bulb there, the electricity moves from the dry cells through the wire, and you see light here. You see light here at the filament, meaning that the electricity is able to move from the dry cells where it is stored and move to the other part. So that is exactly what we call current electricity. Current electricity. So the movement of electricity from one point to another is called electric current. So the movement of electricity, from one place, one point, to another is called electric current. So in short, what we are saying is that this piece of wire, we call it a connector. So the wire carries electricity. So the movement from here, where we have the dry cells are labeled that. So where we have the dry cells, we have stored energy. So the energy is going to be moved from this point through the wire. So that movement through the wire, we say that the wire is carrying electric current. Electric current. So that movement from one point to another is what we call electric current. Electric current. So we continue to understand what current electricity actually is. So it's carried through wires. Current electricity is carried through wires. You can also call them connectors. Wires or connectors. They connect electricity from one point to another. You can also be stored current electricity. Stored current electricity can be stored, like in the case of dry cells or car battery. In the case of car battery and dry cells, we have stored electricity there. So once you connect the wires, is when it starts to move from the dry cells or from the car battery to where it is required, maybe at the headlamps. So when the ones that is stored can be used for a number of activities. For example, it can be used maybe to operate radios, TVs, etc. And more especially when we have that solar panel. The solar panel cannot be used directly when we don't have a car battery or a battery. So it will be moved from where it's generated in the solar panel and moved to be stored in a car battery or a battery, so that now it can be used from there. You can connect the battery to maybe a radio or the battery to maybe a TV, so that you can be able to operate. Because the reason why we can't use it directly is because it has to be converted to the other form of electricity. So what we call the AC, alternating current. So the current is used to operate appliances. Is used to operate machines and other home appliances. Other home appliances. I once explained what an appliance is, because you can be asked that question in an exam. Which of the following is not an appliance? And generally what an appliance means is that anything that uses electricity. Talk of radio, talk of the TV, talk of the iron box, talk of the electric kettle. All those are home appliances. As long as they are using electricity to be able to operate. They are small machines that use electricity. So we are going to look at how to produce current electricity from a dry cell. Producing electricity from a dry cell. So let's see what we require. Producing current electricity from a dry cell. Producing current electricity from a dry cell. Now, I'm saying dry cell, and someone will ask, we have wet cells. Yes, we have. I want to explain what a dry cell means. That whatever is inside that material is solid. Like for the case of the torch cells, we also call them torch cells. The ones that we inside, put in the torch to be able to get light. So the torch cells, inside, if you break that torch cell, which is very, very dangerous, learner, don't attempt it. If, for example, you find the broken one, the destroyed one, you realize there's some black substance, chemical substance inside them, and that chemical substance is not liquid, it is solid. That's why you're calling a dry cell, that whatever is inside is dry. Now come to the car battery. The car battery, there's a time you recharge it by placing it in it acid, meaning that the cells inside there are going to be wet. So we have a liquid there, which is the battery acid. So that's the difference between a dry cell. Of course, we have a wet cell from the car battery. So what do we require? Some materials needed. For us to be able to do this, we need 2 wires. This is very important, learner. Whatever we are doing here is very, very important because we are going to sketch. Each should be 20 centimeters long. Then we have a dry cell, and of course a torch bar. So to be able to produce current electricity from a dry cell, we need these 3 things. We need two lengths of wire that is 20 centimeters each, and then a dry cell, and then a torch bulb. Then this is a procedure. The procedure is connect the cell, the wire, and the bulb as shown in the figure below. Connect the cell, the wire and the bulb. And the bulb as shown below. After connecting, record your observations in your Monton notebook. After connecting, record your observations in your notebook. Let's see what the diagram will look like, because whenever you're connecting something, whenever you're carrying an experiment, you must have a diagram, and the diagram must always be labeled. So I'm going to sketch for you the diagram that you'll get after doing this kind of a connection. So after connecting, you will have, of course, the first diagram will look like this, where you're connecting 3 items. That is the bulb. Then there's a black thing here. You will observe and realize that there's a black thing there in the bulb. Then you have, this is the wire. Here we have what we call a filament. Sometimes you can draw it this way. The filament. This is the bulb, the wire, and so Lana, whenever you are tying this wire here, you tie here. Tie at that point, tie here, and do not tie here. The reason why I'm saying do not tie here is because this point is a negative point. A negative point, this one is a negative point. So this, from this point to this point, that part is positive. So if this wire is coming from a negative source, of course it will come from a negative source. For it to be able to light, must come from negative to be tied on a positive, and this is a negative, what we call a complete circuit. So in the case, we'll have this one. After you have done your arrangement and connection, you'll have something like this. That is a dry cell. Dry cell. Like that. This is negative, what I was telling you, and this is positive. So that positive and then this one is negative, the black thing, negative, positive, negative. So in this case, you have tied your wire here to that point. So from negative to positive, from positive to negative, from negative to positive. And that we call a complete circuit. So in the case, this will have what we call the filament. Sometimes this will be brought to an exam and you are told to label, which is the part labeled X. So if you don't know the part that labeled X, then you are likely to miss that question. Then this is dry cell. Then you have wire. Just like that. So at the end of the day, this connection will look like this. So this one we call it a complete circuit, whereby this bulb is going to light. This bulb is going to light because this is the connector. The bulb you have connected the wire to the positive, then brought to the. Remember, this part is positive. So negative and positive means that they are going to transmit charges. So what are we going to observe? That is what we are going to write, the observations. Remember, we have been told to write the observations. Number one, you are going to observe that the bulb will light when the wire was connected from the dry cell to the bulb. The bulb will light when the wire is connected from the dry cell to the bulb. So this one is going to light because it's carrying electric current from the dry cell through the wire to the bulb, and that's, you see, this one glowing red, and eventually it will light. Now, number two, the wire provided the path for the charge. The wire provided the path for the charge. That is number two. The wire provided the path for the charge in the connection to pass through. In the connection pass through the bulb. So remember what I said, that our wire here becomes the connector. So without this wire, charge will not come from the dry cell to the bulb. But whenever we include the wire, then it will transmit the charge from this dry cell through the wire, then to the bulb, for the bulb to be able to light. And then lastly, of course, the moving charge is the connection. The moving charge in the connection is called an electric current. So that moment, the charge that is moving in the connector, that in the wire, so this wire carries electric current. That's why you'll be told, don't touch naked wires. Naked wires are those wires that are not insulated. They don't have a cover because they are carrying charge. So if you try to touch them, then you are likely to have what we call an electrocution or a shock. You get a shock from those naked wires. That's why it's advisable, if a socket is not well fixed, you are not supposed to touch it because that socket carries electric current that can be transmitted into your body, because in your body you have blood. So any charge that comes into contact with water, because blood is like water, you will likely to have what we call the electrocution, which is the shock that you can get. So that is exactly what I wanted to say in this chapter. Remember, we started by defining what current electricity is, and we said This is a type of electricity that is in motion, moving from one point to another, and we call it electric current. When it moves from one point to another, we say that is electric current. Then we also saw sources of electric current, big dams talked about, and the electric generators, the wind-driven generators, etc. Then we came to how to be able to produce current electricity using dry cells. We also labeled the part of that particular circuit. So this is what we call a circuit. A circuit is where we have a source of electricity, and then we have what is to be used, maybe a bulb, etc. Sometimes we'll come to realize that in the exam you'll be asked, which of the following can make the bulb light? Which of the following materials can make the bulb light? Meaning that the material that you have to use must be a current, a good conductor of electricity. But we have other materials that are not metals, but are good conductors of electricity. Let me just mention them. Materials that are not metal, but can conduct electricity. Which are these materials, Dana? Number one, we have what we call graphite. Graphite. If you look at your pencil, the part that writes is called, the black part that writes is called the graphite. So graphite is a good conductor of electricity. Number two, we have what we call carbon foil. Carbon foil resembles the paper that we use to cover food. There's a paper, a white one, that or sometimes to be used to wrap some meat. This shiny. So that type of paper is a good conductor of electricity. Of course, we have water. Water is a good conductor of electricity. That's why if you touch a naked wire using your hands that are wet, you are likely to contact the charges. So there are other materials that you'll be asked. Which of the following cannot lead to transmission of electricity? Those materials, number one, a material that is cannot transmit current is a glass. Glass is not a good conductor of electricity. So anytime you find glass is not a good conductor. It cannot conduct electricity and other materials. But all metals, underline that and note it. All metals are good conductors of electricity. Not of it, I've said of electricity. All metals are good conductors of electricity. So you can note that down. So in our next lesson, learner, we are going to look into some sources of electric current. We are going to see sources of electric current. I'm going to explain them here, one after the other. So let's be there in our next lesson to see exactly what we have. So may God bless you. Have a very wonderful day ahead.